everybody, welcome back. Today we are working on my map, and the topic for today is trying to correlate which sidewalks belong to which streets. So context for this is sometimes I like to go outside my house, very occasionally, but sometimes, right? And when I do that, I might ask Google Maps, how am I going to get to where I want to go? What's like a fast way to get there, right? Sometimes I have like a good guess, sometimes I don't really know as well, right? And the routes Google Maps gives me piss me off, right? It seems to think that I don't know how to walk, I don't have legs. It thinks that I would rather take a bus than walking 4 blocks. It thinks that buses will come according to schedule and on time, and they don't really. Sometimes they're a few minutes early, and if they're a few minutes early, then you miss your transfer, and all of a sudden, like, the route is like totally boned. And so I want to make a path planning algorithm that kind of allows me to set all of these like tunables for like what I prefer today at this point in time, right? So I value consistency, right? I want the fastest route that I can leave at on average at any point in the day, and I don't think that that provides that. So we're making our own path planner. What we have right now is we have this map. We have little satellite images overlaid, which is pretty cool. Satellite. They're not really satellite. They're drone images or whatever. But and I can go here and I can say, hey, if I want to go here and I want to go, over here, that's great. Send me over there. I could do things like I can say, hey, if I don't want to turn that much, so like let's up the turning cost. You can see the red line gets kind of like straighter and straighter. I can say things like, hey, if I want to go from here to here, the most efficient route is a straight line, but there's a blue line down here which indicates a bike route. If I'm like, hey, I'm on my bike and I'd prefer to go on the bike route, I can kind of set that cost lower and we see the path adjust itself. So we're starting to get like somewhere that's pretty good. But my problem right now is that I fucking hate walking down these like 6-lane streets, right? So if I look over here, right, this is Granville Street, there's like fucking 6 lanes of traffic and like the narrowest sidewalk of all time. I would prefer for it to like route me maybe 1 street over, right? Maybe even over here. Like, it depends. There's like, I think that the area I just happened to highlight on is this like fucking like twisty, windy, confusing area of the city. So in here, it's like, how am I supposed to navigate this shit show to get down here without walking down busy street, right? That's kind of what I want to know. The problem is that the data that I've scraped is from OpenStreetMaps, and they kind of have this concept of like, okay, Granville Street has sidewalks, it has that information, and also has the sidewalks laid out themselves. But what it doesn't have is that this path that I could walk on belongs to Granville Street. So I have like 2 options, right? One is assume that anything that says that it has a sidewalk is like walkable, which is like a little bit tricky because there are some streets around the city, let's see if I can find one, that only have sidewalks on like one side of the street. Let's see, I don't really, here for example, right? So here, there's a sidewalk down here. There's not one up here. Now, I think that this might say, it doesn't even tell me here. It doesn't even tell me that this street has a sidewalk associated with it, right? So in my city, at the very least, mappers have decided that they want to mark the sidewalks individually, and you get better path planning if you can use these, right? You can then say, if I want to go from this side of the street to this side of the street, I have to hit this crosswalk, and maybe you can like add a cost of crossing crosswalks so that you like, you take a route that gives you less light changes and stuff like that, right? So I think planning directly on the footpaths makes a lot of sense. It also allows you to do things like go through the forest, which don't have roads associated with them, right? So like probably I want to keep the idea of like walking along these paths. And so the option 2 is just we have to fucking figure out if this path belongs to a street. Right? And so I think that's the plan for today, is figure out how we can say, okay, this is an orange line. I don't like orange line. How do we make sure that I don't walk along this line? And like you might say, just fucking check if it's close. And it's like, okay, chill. We are going to check if it's close. But when you zoom out, there's a lot of data to look at, right? And so we have to find an efficient way to basically figure out if the thing is close, if it's parallel. You can't just get away with like, is this thing connected? Because like here, for example, this sidewalk has a node in the middle. And, how do I correlate this with this? Who knows, right? Who knows? So I think that we're probably gonna have to do some sort of like, basically like check if lines are parallel-ish, and then check if close, and we're probably gonna have to do some sort of like fixing of the way that we right now are like highlighting these roads is like a close approximation of what we want to do, right? We kind of say, hey, if this point is close by to the center, then we'll select that. So we'll kind of start there. But there's like some flaws in this logic. We only look for points that are like within a certain block. So we're gonna have to fix that a little bit. And then once we have which road owns which footway, we're going to have to adjust our path planning algorithm to support that, essentially. So that's the plan. That's the plan. A lot of talking, not a lot of doing. So let's change that. Let's change that up a little bit. Do the OSM data files have any kind of ordering? I don't know. I mean, I think that if I remember correctly, they're guaranteed to come like nodes then ways, but I don't know if there's a guaranteed order of like the way ways are ordered within the way section, if that makes sense. Okay. So the way that like this works is we divide up the map right now into like a grid. Boom, 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 boom. Right? And like your road might go like from here to here to here to here to here. And what we do right now, which isn't really that smart, is we basically just check we only look at like points that are within our bucket. And then we say like which of these lines for all points that are within our bucket is closest to like the center of our screen. And we can probably like continue doing that. So if I like turn on debug wayfinding, you can kind of see it here. So like the larger the thing is, the closer we think it is to the center. And this looks like pretty well. There are a few cases where it kind of like falls over because if we're like on the corner, or if we're on like the edge of one of our buckets, then it will not correctly consider that street as being part of our like search space. But this is probably a good enough approximation to start with. We can kind of start by just reusing this same logic to try to tie streets to sidewalks. So let's start there. I think, do I want to do this in like the pre-processing step? That's probably where it ends up living. That's what like makes most sense, maybe. I guess if we do it in the pre-processing step, we need to transmit more data over the wire. But if we do it on app initialization, we're like wasting compute. And so the question is, which one of those is like a worse problem to have? I think it's probably okay to waste some compute for now. If it's cheap to calculate this whole thing, then why fucking not, right? We can find, if it turns out that that's expensive to calculate, then maybe we can cache and eat a little more bandwidth to send that data over. And another thing that I forgot to call out, I think, is we have like OpenStreetMap's data is kind of structured in this way where it has nodes, right? So you have like this thing, then this thing, then this thing, then this thing, and this thing. And these have like IDs 1, 2, 3, 4, 5 or something, right? Then we have ways. And ways are kind of like links between these nodes. So we might have like way 1, 2, 4 goes like this. And then we might have way like, 7, or we don't have 7, 5, 3, 1, and that goes like this, right? And these ways have like traits associated with them. Now, the simple my first thought to implement this would be that we figure out which ways are tied to which streets, right? Because like we have like this street here. This like is a way, and he is like associated with West 16th Avenue, right? But it's not super obvious how you would like link these ways together, because like you see like this blue line kind of like turns a corner. So this way is not associated with one street, right? And we could try like breaking up the way so that each way is only like associated with one street, and then we could tag our data according to ways. But I think what is like simpler for us for now is to just tie it to point pairs. So here we have a point here, and we have a point here, and we'll just figure out for each pair of points that are connected, which street do we think they're closest, or they're associated with. I think that's how we'll do it. And probably there's some sort of efficient way to store that. But I think for V0 of this, we will probably just slap that into a hash map and kind of see how it goes. Where our hash map keys will be the point pair, and the value will be the parent ID. And we just won't put things in there if they don't have parents. Maybe. Something like that. Okay. So that's probably all the background we need. Enough to get moving. So, oh, right. So this stuff here, like these points and these ways, these are transmitted over the wire, like as these are like separated with like int max, and then these are just like in all one buffer. So what we do right now is we kind of like iterate over this way buffer one time and then do a bunch of math on all of the stuff in it. And so that's where this building will happen, I guess, is wherever we iterate that stuff. So somewhere, parse index buffer, here we go. Here we construct like this index buffer iterator, and then we loop over the each way, so each like set of node links. We construct this like neighbor map. And then we also construct this like bucket grid thing that we were talking about, based off of the points in that way. So the question is, what do we do now? What do we do now? It's probably, once we have all this stuff, I guess the neighbor lookup is going to be important. So we're going to say for each node, let's look at all of our neighbors, and then let's try to look for all elements in the bucket nearby. So maybe we'll look at like, for now, this is not perfect. But if we have like a line like this, and this is one of our buckets, we'll just look at all other lines that have points in this bucket, which we have to kind of tune the bucket size so far that this kind of works. And then maybe if the path stretches over 2 buckets, we'll look at both of them. Sure. That seems reasonable to me. Okay. So this gives us, when we look up in the way lookup, what do we get out of this thing? This gives us a way, which gives us a. Ooh, he doesn't have a way ID, just a way, which is a problem because we don't have a good way to tie these like ways back to their like metadata. But we can fix that. That's definitely fixable. So let me look at this again. Way lookup. Oh no, sorry, this is wrong. This isn't the right thing. We're looking for way buckets. What is way buckets? Way buckets returns, this returns way IDs. Perfect. That's perfect. That's what we want. That is what we want. Okay, so I guess we kind of are saying that we kind of do all of the stuff that we want to do here after we have all this stuff. So we can kind of do it like here, where we say like, for what? Node. For point lookup dot points, I guess. No. What is a point lookup? Oh, this takes in node IDs. So for 0 to point lookup num points. Whoever said today, we did just go over it, but you can also look in the top right. So this is going to be like point ID. I guess we're going to say, this is like node ID, I guess. We can do what? We're going to look at the neighbors. So for adjacency map, what does like our adjacency map give us? This is probably map data, adjacency map. We have get neighbors. And this is going to give us a neighbor ID. Okay. Then what? We're going to look at us to our neighbor, and we're going to say like way buckets get something about like getting ways. Where is our like map data? Buckets. This is an app maybe? Buckets. So here we are going to get a bucket for a specific latitude and longitude. Right, so we're going to look at a bucket is going to be way buckets get, and we're going to look at the lat point is going to be like point lookup get node ID. This should give us a point. And then here we're going to look at point dot y, point dot x, because it's kind of backwards. Lat long, it should be long lat probably. The fact that I think lat long by default in my head is really confusing because I think xy by default in my head as well. But whatever. Okay, so we have like a bunch of, this is a bunch of, I don't know what this is. A bunch of way IDs, right? So this is all of the like collections of points that go through this area of the map for this point. We'll start there. Now we are going to iterate over each of our neighbors, and we're going to construct a vector from us to our neighbor, right? So that's like, we are this point, we have this, and this are connected to us, right? Boom, 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 boom. And there's like another street that goes by that looks like this. And so we are constructing like this vector is what we want. So we want neighbor minus us. So we want like const neighbor point is the neighbor ID. So the point lookup, get from the neighbor ID. And then we'll say like const like neighbor vec is equal to neighbor point minus me. Now I've completely forgot something here. It's that I only want to do this for sidewalks. So I want to do this for anything that's marked as highway, footway for now. I think that's probably semantically correct. So here we need to somehow find out if our pair of points is part of a highway, footway, which I don't really know how to do right now. We don't really have that information anywhere. Like, we don't have this concept of like, given a pair of nodes, which way are we associated with? Which maybe we should have that. We can like, as we are iterating these things, we can make a like point pair to way lookup. I don't know if that's like worth it, but maybe it is. I guess like we can always optimize later. Let's just start with doing something and then we'll figure it out later. So I guess we want like a stud auto hash map is like the default thing I want to do here. This is the default thing, and this is going to have like a point pair. And it's going to map to a way ID. It's actually going to map to many way IDs. Right? There's a chance that like the same point pair is both part of like one trait and like it could be part of multiple ways. It could be. But maybe we'll assume it can only be part of one way for now, and we'll see if that assumption ever breaks. I'm terrible at doing something, figuring it out later. We are maybe like too good at that, where we kind of just like plow ahead on things without thinking about them. And then sometimes that gets us into trouble. But you know, we can always figure that out in the future. You know, they say, defer all decision making and you never have to think. And we hate thinking. Sounds like there's a tag which indicates that a road has an associated sidewalk. The associated street highway should also be tagged with sidewalk equals separate. Yes, I agree that there is a way of knowing that there is a sidewalk, but I don't think it tells us which sidewalk it is, if that makes sense, right? Like, we have all of the tags here for this street, and nothing indicates, like, there's no like ID mapping as far as I can tell, unless you're saying that there is that and I just missed it by doing something. So you're saying like sidewalk equals separate. Yeah. So what I'm looking for is I'm looking for something that's like sidewalk equals node 1, 2, 3, 4, right? Dude, I love when ML people come in here and like, couldn't you just store the paths and vectors and do some KNN? And it's like, you make it sound so simple. Like just throwing just, or you didn't say just, so you just say couldn't you store that? But I put a just in there in my head. Maybe. I mean, K nearest neighbors. I don't think that's what I want. I need to look at the. We did a series on this at some point. But I need to refresh my memory on this. What does this do? It says it's clusters. It's point clustering, right? So I think that this is like just a worse version of what I want, though, right? We don't want to know like, given a point pair, we don't want to just know like who's around us. We don't want to just group them as like part of some arbitrary cluster, right? We want to know exactly which road we get. And so why would we do that, which takes effort to implement, when we could do this, which takes effort to implement, but is like exactly what we want? And exactly what we want is we have like extra constraints that we can exploit, right? Like, for example, we have a pretty good idea that a sidewalk is going to be parallel to the street that it's associated with, right? That k-nearest neighbors doesn't give us that. Unless I'm missing something that you're saying, but I don't think I am. And also, if like, you know, couldn't you? It's like, yes, maybe there are other things we could do, but I'm gonna do this because this is what I want to do. Okay. So we have A and B. This says, given a point pair, which way are we a part of? This is the first step. The first step. And this is fine. This is kind of shitty. But whatever. Then we're gonna say like, put. Didn't we write something very similar to this the other day? This looks like very familiar. But whatever. I remember seeing like point pair. Some mappers therefore add name equals or street colon name equals. Yeah, but they that would be nice, but we don't have that, right? Like we can just tell by looking at this that we don't have it. So maybe what we should consider is after we do all this, maybe it would make sense to try to contribute something back, right? But for now we're just gonna do the math. Okay, so we're gonna put a node ID, B node ID, and way ID. Okay, I guess this is kind of gonna be like an implementation detail from the interface. And we're gonna say min is min A value B value, and max is max A value B value. So we make sure that they're sorted so that we only store this one time. And then we say self inner get or put. We put in the key, which is going to be const point pair. This looks so familiar. I'm just going to double check that we're not like missing the fact that this exists somewhere that we haven't pulled in. So what we were working on the other day, we were working on street filtering. And this would have been in our path planner. This would be in our node cost lookup. Would have been where it is. Node pair cost multiplier map. Yeah, this is exactly the same fucking thing. This is exactly the same, where we put a thing and we get a thing, we make it the node pair, and we only want to store one per pair. So we should just abstract this into a generic thing. So this is like node pair map. And this takes in a type and returns a type. This is the way of generics and Zig, is that you write a function that returns a type, and that function generates a new struct inside of it. It's going to look very, very, very similar to this one. Very, very similar. Boink. But instead of this being a type, he's just going to return. And this is going to map to T. Okay. Node pair is going to go inside him. I think that's an implementation detail. And this all says this is like value T. This is also T. And then the rest of this stays the same. So then we can say pub const node parent multiplier map is equal to a node pair map that of F32s. Then all of this goes away. 117 F32 goes to T. Yeah, true. And then down here, this or else has to have like a default value. I guess we just won't return the default here. Here, we will say that the user of this thing has to choose to figure that out themselves. Okay. And then wherever the fuck we were over here, wherever the fuck in app, let's just comment this out for a second because we're not doing it yet. And let's just kind of see where it falls over. 106. Right, so this is also work in progress. Okay, so he's mad at get cost in path planner. Twitch chat LSP, perfect. So here he's gonna say or else 1.0 because the node cost is, we were just like assign the default externally, that's fine. 407 where we have put cost, this becomes put. And 387, same dealio, put instead of put cost. And we're so back. We're so back. Okay. So now this point pair to way thing goes away. Because we can just automatically figure that thing out. So we have like var pp to way. We already used pp somewhere else, so we should call it for path planner. So we'll just say point pair to way. It's fine. Map data dot node pair map going to way ID. Cool. We initialize this with some allocator, and we error defer point pair to way dot d in it. Boom. Okay. Now we have to go back to actually trying to do something, and that something is we have our neighbor vector. Oh wait, no. This is still we still don't want to do this here. We have to still build the point pair to way lookup, which I guess is going to happen as we walk our index buffer. So here we say here, I guess we just say node neighbor or point pair to way put, and we have node ID I guess this is our neighbor. So we have node ID neighbor, and the way is way ID. That seems reasonable. He's mad about something. Expected type F32? Shut the fuck up. Why? There's definitely no expected type F32. Right? Am I high? I see no F32s anywhere in here. I guess he is kind of mad that this doesn't work. I think the LSP might just be a little fucked up. No, expected type F32. I mean, he is consistent. Map data zig 117. Am I fucking stupid? First of all, this should be inner, not costs. I can't tell if I'm just like losing my mind or it's actually not broken. Like there's like a bug. Parameter declared here, T, K. T. T is a node pair map way ID. So way ID is not a float. This is a way ID is a way ID. Neighbor is a node ID. Node ID is a node ID. So what the fuck is it complaining about? Am I stupid? Like, surely it's not the cache getting fucked up. Surely. I mean, it's consistently fucked up. Hash map, node, map data zig 117. He's expected type hash map, node pair map F32. Whoa, 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 whoa. Whoa, 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 whoa. Index zig 105. App.zig 91. $4.50. Dude, I'm losing my fucking mind. I'm losing my mind. Point paired away. There's no float 32s anywhere in this. Oh, I'm a fuck me, fuck. Everything here has the fucking type alias. God damn it. We're fucking dum-dums. Dum-dums indeed. What a little tricky in there. Error union is not to be ignored. Fine. There we go. We got there, guys. We did it. Okay. So now we have, I mean, I guess that's the whole lookup. So here we say return point pair to way. And here we have a point pair to way map, and which means that we kind of need like a point pair to way map is equal to map data node pair map of way ID. We are getting there. We are getting there. So now we have const point pair to way is equal to index buffer obs 3. We might be able to just like unconditionally get rid of this shit. That seems possible. Because we might only need it to walk this stuff at the beginning. Okay. So now we look at our neighbors and we say like, hey, what's our way? Point right away. Get node ID. I guess here it was like node ID is the strong type of that thing. We should probably make like iterator types for these so that I don't have to do this like manual casting to strong types. It kind of defeats the purpose. A little bit. But we'll live. Missing semicolon? Oh, there we go. Okay. Node ID, neighbor ID. This is our way ID. And here we should be pretty damn certain that this exists. If this doesn't exist, was like, how the fuck did we find a neighbor? No neighbor for no way for point pair. This should never happen. This should never happen. Okay, so now what? Adjacency map, get neighbors. This is our way ID. So here, right, here we're trying to say, if our way does not have footway in it, then like, fuck off. Yeah. So here we're looking for like metadata way tags at way ID. So for this, I guess, if I remember correctly, this should be like we have way tags is like a array where each element has keys, so like highway and like foot, and then the values next to them. So the values would be like highway, secondary, and foot, yes. So the way these kind of are like packed is that like this goes with this and this goes with this, and this is an array of 2 here, and this is in an array of like variable size for how many ways there are. So this here, we should have the tags for this way, and then we say for tags 0 len. It's like something like this. It's like tags 0 I is the key, and the value is tags 1 I. It's like something like this, and then like how are we supposed to check? Here we want to say like key is highway and secondary. Pigeon Guided Missile, thanks for the tier 1. 3 months. That's crazy. That's crazy. Appreciate it. Appreciate it. Okay, so this is a fucking shit show. This hurts my head so much. 4, 4, 4, 4. But I do think we are kind of getting there. I think that we need to break down this problem so that we can get some sort of like intermediate success so that we don't get like fucking lost in the sauce. So I think probably let's maybe visualize all point pairs that match this trait, which we can kind of do by saying that we will have like an index buffer object that we will get from the renderer. So we'll say that this is going to be like ppviz is going to be an element array buffer or an index buffer object, and we'll say like so what we say like GUI gl create buffer ppviz is equal to this. Error, I'm not going to deal with error differs right now. ppviz equals ppviz. Whoever said exclamation mark today, you can read in the top right / title. The 2 of those things hopefully together. Actually, it's the title. The title's just wrong. That's annoying. Correlating sidewalks with streets. It's not happy hour. And we'll say replacing Google Maps. Nobody reminded me to fix the title. What are you guys doing? Come on. Instead of blaming myself for my problems, I can blame you for my problems, and it's your fault now. That way I don't take any responsibility for my failings, and it's perfect. Then I can continue thinking forever that I am perfect and everybody else is the problem. Okay, so we are going to maybe attach some indices to this thing. So okay, let's split this up. Okay, let's make a function. This is crazy. We're getting fucking wild out here. So here we're gonna say, what are we even doing? Like, we're trying to like find sidewalk streets, which I don't like the idea of hard coding key value pairs in app, but whatever. We might move this into pre-processing or something later, so I don't have to put it here. Okay. I guess he is going to take in whatever stuff we were looking at here. So this kind of comes down here. This goes like this. And then we need like point lookup is a point lookup. What else do we have in here? We have weight buckets. And we have an adjacency map. Okay, and then we have point pair to way. Point pair to way map. Okay. And then we have the EBO as well. Index buffer. I think that's it. Did you consider using a quadru for storing things like location? I'm aware that what I have right now is not really perfect. But my understanding is that like any improvement is basically trying to exploit the fact that nodes are not like evenly spatially distributed. Somebody linked me R trees at some point. I assume a quad tree is just very similar to that. Let's see. Oh yeah, it's very similar. Yeah. I mean, I can just tell from this picture. So the reason that you would want to use this is if you have like high point density in one area and you kind of want to keep like even distribution of points per bucket. I don't really care about that so much, and also like the point density of the map is like pretty uniform. So I think our naive solution of just splitting everything into squares is like good enough, and the savings that we need, the like improvement that we need, is a way of correlating which buckets a road actually transitions through. Like no matter how whatever data structure we use, we have to solve like this problem where like this line with 2 points is going to go through like 4 or 5 boxes. We need to solve this, and I think that even with like this doesn't even help us with that, if that makes sense. So I think it's like one of those things where it's like it's worth knowing it exists, but you can just look at this picture and go like, meep mop, like it doesn't matter. That being said, I didn't read the Wikipedia page or understand the algorithm, right? So maybe me looking at this picture and going beep boop is like fucking stupid, right? But that's my assumption for now, and we will keep rolling with it. Because you know we say we never learn, we never think, we only do. Fucking stupid. Okay. So I want to basically loop over every point pair and just see if we can figure out if we know that it is a highway footway. That's what we want to start. And so what we're going to do is we're going to create a buffer of points. We're going to say var buff index buffer points indices. We'll call this EBO. This will make it easier. Element array buffer object. Then we can call this index buffer is an array list of U32s with an allocator. Yeah, as far as no arches are related, thanks. That helps me better understand what's happening. No problem. No problem. If you feel like you need help understanding, that means everybody else probably does too. So I don't mind answering questions. It's kind of like the benefit of having Twitch chat instead of just doing raw YouTube. The other benefit is that I'm forced to do everything live and I can't hide stuff, and I don't have like the temptation to edit stuff. But the other benefit is you guys get to help me make the videos better because you can ask questions that I can't get out of my own head. And so I can make assumptions about what I think other people are thinking, but I don't really know. So, it's nice. Okay. So let's start with just trying to figure out if we are away with this attribute on it. It's going to look something like this. And we're going to say, I guess we're going to want the way ID. We're going to do this way tags search as well. And here we're just going to need to maybe initially pull up the like string table. Jesus Christ, this is crazy. That's a lot of things that this needs. We can like get highway. So we'll call this like a sidewalk key, and the sidewalk value is what was it? Highway sidewalk. Highway footway. So we get these things from the string table. These things are expected to always return something. And so now we can say here, if k is equal to sidewalk k and v is equal to sidewalk v. Oopsies, press that button twice. Then this is a success. This is something that we want. So surely we should say something that's like way tags contains, and we're going to look for key usize and v usize. And we're going to look up the like what is this? Metadata way tags is tags. So this is metadata.tags is what we want here. There we go. This should make this a lot simpler to work with. Okay, so that's kind of this inner loop here. We kind of say, well, we have these tags, and if the key, this is going to call like, we're going to invert kind of which one is named. This is, geez, tag v, tag key, tag key, key, tag v, v. Return true, else return false. Boom. Now I can go down here and we can say if const way tags equal this, if way tags contains, nope, way tags contains, way tags sidewalk key sidewalk value. There we go. Holy, this took us a while to get to anything. So if the way tags contains this, we're going to kind of like push these indices for these 2 points into the index buffer. So we're going to say index buffer append slice, and it is node ID value, neighbor ID value, and Xerox FF. So this says like, essentially like at the end of this, we're going to have an index buffer that has pairs of points separated by FFs. These FFs tell OpenGL, WebGL, whatever the fuck you want to call it, put a break in the line here. Essentially, it's like a point that doesn't exist. So then we can draw all of these things at once. Now at the end of this, we can say we want to do like GUI bind buffer as a GL element array buffer of EBO. And then we're going to say like, there's like a buffer data call somewhere. And we're going to say, hey, I want to use index buffer items pointer and index buffer items len. Okay, so all of this to say that we should have an element array buffer now that we can use in our render call to show that we have successfully found sidewalks. Hey, I was looking into working with OSM data. How big of a pain in the ass would you say it is? I'm mostly into looking into recreating something like Strava. I mean, it's a lot of data, but I mean, nothing I've looked at so far is like crazy. Right? It's just a graph where the edges have attributes. Is essentially it. It's not too bad, right? Like the raw data just looks like this, right? Node. So you have a bunch of nodes with IDs, and you have a bunch of ways that have like links between nodes. And then they say stuff like, I am a cycle way. I have one way, right? Like it's fine. Nothing crazy. You know, how much of a pain in the ass it is like, I mean, I don't really know if it depends on what your view on working with that type of data would be. But I don't really see how it would get easier. Like, it's like, I think the hard part is that there's lots of data. You just have to figure out how to work with it. Okay. So I think here, we should be able to call find sidewalk streets on initialization. With alloc and like point lookup and like, what else does this thing need? Way buckets, adjacency map. Okay, wait, let's just fucking do this. Copy paste this shit. This will be easier. Find this, delete till this, find this, delete that. Okay, so this is going to be alloc, ampersand, EBO. Okay. And is this thing failable? Surely, right? Yeah, it should be. It's not, but it should be. And this is ppviz here, not EBO. And then Then now in our render loop, we should be able to just say like, hey, I want to render this index buffer. And I guess we need the number of elements in it. And we also want to set the color to like fucking like green or something, just so that we can see it. Okay, so this means that like this guy probably wants to return how many things we put in here. And then here we have ppvislen. And then here we just need to return the index buffer length. I think that this should do something that we want, but I don't fucking know, man. I don't know what I'm doing. He's mad. What the fuck? How have I fucked up so bad that he doesn't know what, like, he thinks that I'm totally out to lunch? What did I just do? This is fine. This is fine. This is fine. Dude, it's I'm fucking lost, man. Somewhere I've just like done some sort of invalid syntax and I just can't find it. That's super cool. Probably this. Metadata needs to come in here too. Holy hell. Metadata, const metadata. Look at this fucking function signature. This is crazy. Metadata here. And I knew you were trouble when you walked in. I'm gonna get fucking banned because, dude, I got fucking demonetized on YouTube for playing that that video of Taylor Swift's trouble with the goat, like subbed in. You know that one where it's like where they just go and then they replace the with the goat. You guys know what I'm talking about. Surely. This should be find ID. Not yet. Anyways, they demonetized me for playing that like 10-second video, which is crazy. Is it more exhausting to just program live on Twitch than private? Definitely. The tier list goes by myself, Twitch, for YouTube. For YouTube is the worst. Because there's like pressure to like finish a thing. When I'm coding on Twitch, there's pressure to keep going. And when I'm by myself, I will take a break every 30 minutes and do something else. So there's definitely something there, but I mean, also it's like, there's, you know, it's more exhausting to go to work than any of this. So like, I can only complain a little bit, right? There's like, I've been kind of like mentally joking to myself a little bit where it's like, I'm like an athlete, guys. Me and athletes are the same. I mean, not actually, but like there is something about like, you know, you have to be on for 4 hours and you have to be like I have to make sure that I am prepared to perform at like not peak, right? But if I am having like a really off day, that's really bad because like it just feels so much worse having a bad day when like, you know, 150 people are watching you have a bad day. And like at work, if you have a bad day, you just go in and you sit at your desk, right? You just fucking sit there and you don't do anything. But you can't really do that when you're streaming. So it is like there are downsides, but the upsides are like enormous, right? It's like it's very fun to talk to you guys about stuff while it's happening. I think like my favorite part of work was always like collaborating, right? So like going up to my coworkers and being like explaining a problem and having them talk me through their ideas and their solutions and like just the idea of like, you know how like I'm always anthropomorphizing code and like that's just like a side effect of like having fun talking to my coworkers about stuff. And so like there's like the upside is huge. It's just that there are like it is tiring for sure. more tiring than doing it by yourself. And what's less tiring than all 4 or all 3 of those things is just not coding at all. Right? Like that's just nothing. You're just like sleeping. I was worried I'd just go silent. Yeah, I mean, I had to practice that. Like before I started, I turned on the camera and just like did this for a month with no audience, like without pressing the go live button. And then I VOD review like a fucking freak. Like I don't know if you guys do this when you play video games, but like when I play video games, I like record with OBS and then wait, like watch back when I die, and then like think about it, and I'm like, what do I do better next time? I just did that same thing for this, which is like fucking like psychotic, but it's the way I go through things. So, member function expected 1 argument. He does need the neighbors for his node ID, huh? This guy is mad about this. Min-maxing gaming? Of course. I mean, if you're not min-maxing, what the fuck are you doing? You have to min-max something, right? Like, I'm not saying you have to min-max, I'm not saying you have to min-max, like, your performance, but I think at the very least, you should be min-maxing whatever you're trying to get out of it. If you play a game for fun, you should be min-maxing your fun. And if you're playing because you like winning, you should be min-maxing your winning. Anything else is a waste of fucking time. Is this working? Tons of index out of bounds happening. Min-maxing my mental health by never watching or recording myself doing anything for any reason. Yeah. Yeah, that's pretty fair. That's pretty fair. Let's run the local version of this, because surely this will crash on off rip. No ID. No ID. Highway's not in there? Oh, fuck me. This is doing pointer comparisons, which is fucking stupid. So we actually have no way to go from like string to string table. So this should be like find by string content. And S is const u8. Yep. And here we kind of do the same thing where we walk everything in here, but instead of doing pointer comparisons as like our shitty little optimization here, we should do mem copy. So stood mem equal which is item and S. Then this guy is find by string content. And then here we should actually rename probably find ID is confusing. So we're going to rename this to find by pointer address, just to make it really fucking clear. Because that's like a kind of like weird thing to be doing ever. Hanus, thanks for the prime. Appreciate it. Or that's not a prime, sorry. Tier 1. I can read. That's a fucking lie. Guys, I'm so bad at reading. I'm sure you guys have noticed every time I open a website, I like look at 2 pictures, scroll the page really fast, and then just like kind of guess what I think it says. Which is why I just guessed that said prime, because I just assumed that everybody will only give me primes. Okay, so that works. So we can Python HTTP server, and now we can hope that we see all sidewalks highlighted. That's really all we were trying to do, which is a big win for us. Look at that. All of those sidewalks are highlighted, which means we found them all. And so now we can actually say, we're still working on this, but now we said, find all sidewalks. Jeez Louise, that was an hour. Holy fuck. Good thing we allocated a whole stream for this. Holy shit. I was worried when we started. I was like, maybe this will go too fast. And boy, am I a fucking idiot. Okay, so now we have successfully found all the sidewalks. So let's invert this. And we'll say if it doesn't have that, we continue. On to the next neighbor. Okay, so now we can start trying to figure out which ways are associated here. So we're going to say like for bucket, what's in the bucket? Way ID. Other way ID. So we're going to look for all the other ways in our bucket. Then what? Then what? I guess we'll kind of like make this like function bucket way score. Way parent score. And we'll say that we have like node pair vec. Let me think about this. Sorry. The vector will not contain its position. So let's do this. We'll say A point, B is a point. And we are going to also have the way ID, or maybe just the way. Okay. And this is going to return like a float. And then what? We need to then call this thing. Maybe calling it score is better. Let's just say like, no, I guess score is good. I was gonna say like maybe it should just be like, is the street a parent of my sidewalk? But really we want to find which street is the best parent of our sidewalk. So it being a score thing makes sense. I don't know what that score is gonna look like yet. But that's okay. That's okay. Okay. So here we're going to look at point, neighbor point. And I think way came first, so it was ways. Do we not have our way lookup? Let's add another fucking thing to this massive list of things we need. Way lookup, ways, way lookup. So this is gonna be way lookup get way ID. Where's our way ID? For adjacent map, blah blah blah. Way ID. Here we go. Yep. And it's not called way lookup, it's ways. So that means this neighbor vec goes away. It's fine. This bucket isn't used. So here we still need to go like for bucket way ID. Other way ID, I guess. And that means here we want to get the other way ID. So we want to say, hey, are we like them? That makes sense to me. That makes sense to me. That means that this now has to do something. So we're going to say like min score is definitely like infinity, surely. And this is like a way has like nodes A, B, C, and D, right? And so we're going to iterate over each pair of these and see if it feels like it is good here. Let's start by just picking if like we'll look at each point and we'll see how far it is from each of our points. That's a bad metric, very bad metric, but it will at least let us like get the scaffolding of the code right. And then we can come back to doing something more intelligent, right? Like eventually this is going to have to turn into, we have this and we have this, right? And we're going to want to basically find, I guess we're going to have like, we're going to want to find the closest point on the line. So since it's 2 line segments, it's going to be something like one of these 2 points will be closest, probably, not sure. And then we're going to want to see like something like this is worse than that or something. And then we're going to want to say like close is good, far is bad or something. But for now, we'll just do min score for way node IDs. We need, so this is going to need our like point lookup to turn our way ID into a thing that we can interact with. Way point is equal to point lookup get node ID. We say min score is equal to the minimum of way point sub a length and min score. And we do the same thing for b. And maybe we even do length squared. Fuck it, we just do length for now. We can always do length squared as an optimization later if we need to. And then we just return min score. Okay. This now needs whatever the fuck that was. Way lookup, I think it was. This comes before the metadata. So this goes here, this goes here. Way buckets get only works with non-const. Surely that's not required. Surely this can be const, and surely this can be const. Way parent score expected 4 arguments found 3. So this now just needs our point lookup. Nope. Yes. Okay. And now we need to do something with this score. What do we do with the score? So for this point pair, we want to find the street that has a score below a certain threshold. So I guess we want to look for the smallest score. So I guess we'll say like the min way ID is equal to undefined. Min way score is equal to max inf this. We say if score is less than min way score, min way score is equal to score, and min way ID is equal to other way ID. Now at the end of all this, we can say if min way score is greater than threshold, we do something. We have to like correlate that way as our parent. So I guess now at the end of all of this, we're going to want like a tying of us to our parents. So that's what this like point pair to way map is. Is this used anywhere? We do get point pair to way. That's actually not it. We wanted point pair to parent, which is actually the exact same type, which is kind of funny. Weird. So if, in this case, we say point pair to parent, put, we have us, which is node ID, we have our neighbor, and we have the min way ID. And this is only valid if there was one. So we say if min way score is not equal to std math inf, which is kind of fucking bullshit, but you know, shut the fuck up. Okay. Okay. Why do you write code in terminal? Because nothing compares in my mind to Vim. Yeah. I don't have to go into more detail on that. Like I used VX Code for a long time and it's great, but it just feels clunkier than just using Vim. And I need the Vim bindings, and I've kind of used Vim long enough that I feel it if it doesn't work quite right, and it never works quite right outside of Vim. Okay. But I mean, for a long time, there was no way for me to get like effective call hierarchy out of this, and I will say that call hierarchy is more important to me than that. But now that I have that ability, one, I don't even use it anymore, but it seemed very important to me at the time. And two, it just feels, it's, yeah, if I can get away with it, it's better. KD trees sounds a lot like the thing for location-based search, where they have splitting planes which cycles as you go on the tree. All nodes in the left subtree are one side of a splitting plane. This seems like something that would probably be good if we're trying to min-max like time complexity. So this kind of makes it so that like we know that like we're close by to all these things, assuming that the splitting planes are like sane. I'm not sure if this is better or worse than the K-tree stuff actually, but I think that this is one of those things where I think that the bucket lookup is not at all a limiting factor right now, but maybe one day it will be. Okay, so now I think what we want to do is we want to make it so that when we highlight a sidewalk, we see which street was picked as its parent. I think that's key here. So we are going to stash this shit. And on hover, we're going to look up the parent in here. Jesus Christ. There's getting to be like way too much state in here. Which is annoying, but we'll live. We'll live. So this is on mouse move probably is where we do this shit. And here somewhere I guess we know which node we are looking at. Somewhere we have this is so much code. We need to split this shit up. This is really bad. Okay. So somewhere where is the part where we fucking figure this out? Way node IDs calc min way segment. Oh, right. So this calc is a closest way calculator. Here we go. Here we go. So we find our closest way. And what does this return us? It returns us a way index and a segment index. So we're going to do like calc way index. So we have like node ID here. And for now, let's just say that we are selecting, like we can't select a single node. We have to select a pair of nodes for this lookup to happen. So here we'll say if, well, I think that actually the min-way segment is always guaranteed to be the lower one, if I remember correctly. Nope, it picks the closest one. So fuck, that's annoying. Min-way segment. It's almost like we need to stash this decision as well. Like we almost want to stash like his neighbor. Which I think is fine. Which is fine. So here we say self neighbor segment is equal to self segment index. And here it's +1. That way now, after this, we have neighbor ID is equal to this, which is now guaranteed to exist. And then we can do something like self point pair to parent get node ID neighbor ID. So we'll call this parent way is equal to this. And then we just want to draw that thing. So bound renderer render selected way, and this is going to be getting the parent way ID, and then we will set the color to like, blue for now. And this is going to be like if we have a thing. If we have a parent, we do this and we render that parent. Oh, that feels like it might work. Oops, this is not this. This is this. Yes, 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 baby. We fucking are getting there. Oh yeah, I think that'll do it. I think that'll do it. So what this should do is take 1,000,000 years to fucking start up. And then when we highlight this... Oh, yeah, okay. So it's highlighting this. That's interesting. So this means that it's doing something. Highway, footway. So this actually somehow didn't find one. Okay. I mean, I think that's like on the right track. Forgot to remove a get call, I think. I don't think so, but maybe. Some of them are not finding parents, which feels odd to me. Or the parent that is being found is like not rendering for whatever reason. Like the fact that this isn't finding this is very confusing to me. Maybe we'll also log if we found one. Like on the right side. Maybe instead we'll just say stood log debug no parent. That's good enough for now. Good enough for now. Because I want to know if I just can't see what it's selected, which would be somewhat reasonable, or if it's just not happening. I guess we need to log no parent or yes parent because otherwise it gets like kind of folded. And we need them to be unique so we can see, because this number going up is hard to track. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. It's also not cheap to figure out. Jeez. So this is yes parent. So what were we looking that we were like kind of like surprised that there was no parent? Was it like over here somewhere? Yes parent, yes parent. Yes parent, yes parent. No parent because it's not a sidewalk. So I think that this is doing something. Oh, it's finding another sidewalk as the parent. That's why it's confusing. Right. So we're gonna have to do some like filtering. But at the very least, it seems working. Yeah, no different map. Never mind. I mean, to be fair, there's like fucking like 40 different maps to look at. There's like too much data. I'm starting to have trouble like tracking it all. What we do in chat? Replacing Google Maps? Yep, replacing Google Maps, baby. Right now we're trying to figure out how to figure out that this sidewalk here is associated with this street here. Which we're getting close to. We're getting close. We at least have the concept of mapping a thing to its parent, and now we just have to get the right math to figure that out. So I think, let's see. Calc. What was it? It was like calc way parent score. Here we go. Okay, we have something, and now we can start implementing. So I think very clearly we're going to need the vector between A and B. Right? We're gonna want to make sure they're like relatively parallel. And I'm just trying to think, what else do we found now that it's pretty fucking clear that we don't want the parent to be a sidewalk. Right? So here we're going to say, hey, if the other way contains this thing, Jesus Christ, dude, this has to get cleaned up, but for now, we won't. So we're going to say other way tags is other way ID value. If way contains the other sidewalk key, then we continue. Fuck this shit. Then at least we'll only be looking at things that aren't what we're trying to filter out. Now this, we're going to do something like, okay, parallel score. They are parallel if we want to lower the score. We want to lower the score if they're parallel and essentially make the score infinite if they're not parallel, if they're perpendicular. Is that true? Is that true? I don't know. I don't know. Because we have like distance score is easy. Somewhere already we do the point to line distance in that like way calculator, closest way calculator. So here we have closest point on line already factored out. That's so huge for us. That's so big for us right now. So we can look at our 2 points and figure out, we're going to use like our 2 points A and B. And we are going to look at each segment of this way. So for way 0 to way node IDs len -1. So then we take the I guess. Const node ID is equal to way node IDs I, and node ID, I would call this like way A and way B. That sounds right to me. Waypoint A and waypoint B. And now we can say, like, we look for the closest point on line from our A to waypoint A to waypoint B. Something like this. Okay, so this is going to be for both A and B. For our 2 points on our lines, how close are we to these pair of points? So we're kind of saying, like, this is us, right? This is them. And we're saying, is this close or is this close? We're kind of finding like these two distances, which isn't really perfect because if we did like this point wouldn't necessarily find, this point would try to match here, which isn't great. And this would match here, but it's good enough. Good enough. It doesn't have to be perfect. It doesn't have to be perfect. Because I think that like conflicts here are going to be relatively low. And even if we miss some street to sidewalk correlations, if we get the vast majority of them, then the path planner will do the right thing anyways. Parallel with dot product not close to 0. I agree with that. I agree with that. Now, what I was trying to figure out is I don't know what I want like the curve to look like, right? If we did 1 over dot, we would get something that's close to infinite if they're completely perpendicular. I just don't know if I want something infinite if it's completely perpendicular, right? We might want like want like some maximum cost minus the dot product times that maximum cost, right? So we'll get there first, but let's start with the distance score. So we're going to say dist score var dist score is this, and then we say dist score is equal to the minimum of the existing dist score or this other thing. Okay. then our min score now just becomes min score is equal to min dist score min score. And then I think that we will probably multiply the distance by the turning, like the parallel cost. Lin point. Expected number found lin point. Point. B is a point. A is a point. Oh. This is a closest point. Okay, let's do this. We're gonna, do we have, like, closest point on line sub A length? Sub B length. Good enough. Good enough for now. Okay, you know what? I am fine with doing infinite. It does, I don't know what, like, how Zig handles divide by 0. But we'll figure that out. I guess we'll just handle it manually. So we'll say, A sub B is, AB. It's crazy stuff we're saying right now. Then we're gonna say way AB is way point A sub way point B. And we'll do AB dot way AB. This will tell us essentially dot product. We probably need these to be normalized actually. So this is going to tell us like we have this, we have this, we have this, we have this. Dot product gives us this distance here. And so if this distance is 0, is close, like big number, it means that our lines lined up this way. And if it's small number, it means the projection was very, very small. Dot product is equal to the product of their magnitudes. I guess we could just do it that way instead, but I think if we like to calculate magnitudes, you need to run calculate length anyways. So just doing in normalized space just makes more sense because you have to calculate like that. You calculate length to get the normalized vector. It's probably fine. It's fine. It's fine. So here we'll say, dot. I guess we'll call it because I don't have a good name for it. If dot equals 0, we say. This comes after the disk score. It doesn't really matter. We'll call this parallel score. Parallel score is equal to 0. I guess we'll make it undefined. This is a float 32. If dot is 0, parallel score is equal to stood math inf. Fuck it. Right? We'll just say if they're fucking perfectly perpendicular, then fuck this noise. Else, we do so we want it so that when we multiply these things together, the score gets smaller if the thing is closer to 1 and bigger if it's smaller. So it's 1 over dot. I think. Because this is going to be absolute value. So here, as dot gets farther from the perfectly aligned, this number gets smaller. It caps at 1. And so as it gets smaller, the parallel score is going to get bigger, which means that we can multiply down here disk score times parallel score. And this will give us a big ass number if they're perpendicular. Smallest number if they're parallel. Sure. I don't fucking know. That seems like it might work. We don't really think very hard around here. We think just enough to do something that maybe or maybe not will work sometimes, maybe. Okay, what the fuck is going on here? This should not be happening. These feel pretty good. This is interesting, and this is interesting. Like, the fact that these are matching this seems really fucking wrong. Parallel score 1 over dot. Okay. Distance score. I wonder if just multiplying these doesn't make sense. Might not make sense. What we should do here is maybe we color. I was going to say we color all of the options, but I don't think that really makes sense. Well, I need to inspect this some more. Cross product of parallel vectors is 0. Yeah, but dot product should be fine. I don't really understand. It looks like it's like kind of working for parallel or for like horizontal. Oh, wait, this is. Oh, hold on. Let's try on debug wayfinding. That will help us understand. Right, because here it's like which of the ways we are picking, because we're not highlighting which subsegment of a way we're looking at. So that could be kind of adding to the confusion. No, I mean like very clearly here, this is the selected segment, and we are not picking this. So like what the fuck is going on there? It's almost like it works for horizontal. Oh, here it's working for vertical. This is fine. This is fine. Yeah, there's something wrong here where these are like almost perpendicular. This is fucked up. So what could be happening there? Distance score. Length is always positive. We are taking the distance between us and the closest point on the line and subtracting A. Okay. So I could see an argument. I could see an argument that like here, the closest point on this line is like 0. Oh, right. That makes sense. So the closest point on this line is 0, which means that no matter how much our parallel score goes up, this will always be 0 because we just multiply them together. So that's probably what's happening here, is that we need to set a minimum here. That's interesting. That's interesting. So we need like something that's like, my points are close. My point is close to the line. But the parallel, it's almost like maybe we add these two together instead of multiply them. So if it's really close, but it's perpendicular, no good. If it's really close and perpendicular, great. And if it's parallel but kind of far, that's also like kind of okay. That feels right to me. That feels better than multiplying now that I think about it. Whoever said abs dot, we absolute value the 1 over dot, so it's fine. Okay, so the roundabout definitely fucks with us over here because this, I guess this point is closer to this roundabout than it is to here, which is true. It is true, and like I guess the parallel score isn't offsetting that enough. This is fucked again. This should not happen. We need our parallel score to like cost more. Like, do we just do like this? Is that stupid? So parallel score, as dot goes to 1, this becomes like 5, which is not what we want. We kind of want to go to 0 as dot goes to 1, huh? We need this to be like 0 to 1 goes like 0 to infinity. No. Infinity to 0. Surely there's a function that does this, right? It's like just 1 minus the score. 1 over 1 minus dot. So here, if dot is 1, this will become infinity. Fuck, that's not what we want. Dot over alien times bln. I feel like I'm missing. I think there's some sort of like inversion that we need. I'm a little confused. Hold on. So here we have the 0 is infinite. It's just the 1 that goes to 0 that we don't have. We just subtract 1. We just subtract 1. Right, so this graph, here, we can draw it, right? We look at Wolfram alpha. We look at 1 over x. What the fuck did I just click? I've never seen this before. Oh, I clicked that. Right, so 1 over x from 0 to 1. This will always end up at 1 here, but if we just subtract 1, it'll end up on 0. Someone said natural log. Let's just look at that. From -1 to 1. So this goes towards 0, so we could just like invert it or something. Which I guess is the same as log x, right? Doesn't really matter. Natural log versus normal log, it's the same shit. Oopsies, log x is what I wanted to do. Yeah, I'm gonna do this first, I think, because I think this is cheaper to compute. Right, if we do 1 over x minus 1. This does give me like a shape close enough to what I want, so I'm just gonna take this first and we'll see what happens. We'll see what happens. I'm sure that there's some more mathematical reason that we could make that one is better than the other, but I don't know it, so instead of thinking about it, we just do something. Yeah, that feels pretty damn good so far. Let's try to get an area with like, let's try off debug wayfinding. I mean, that feels pretty damn good. Where's like roundabouts that were fucking us earlier? Where are roundabouts in this city? Like on the bike routes somewhere. Roundabouts, roundabouts, roundabouts. Surely. Here's one. This is weird. This might be on a border of a bucket. Our bucket search is kind of fucking stupid. Where if we're on the border of a bucket, like it's not searching this street. I don't think. That's my guess right now. If everything else kind of works okay. Interesting that this is picked. What is that? That is a highway residential. Yeah, that's really fucked up. I wonder if we want to take the average of these two. We want to take like the average of both of these maybe? Or the sum of both of these? Right? Like right now we're kind of saying which one of these has like a smaller distance to a street. But we kind of want like which street do you both agree with the best? "45 degrees are like really fucking with us here. Which makes me think that we want to wait we want parallel to have a higher cost. Is kind of how I'm feeling looking at this. Or maybe we like even like threshold the parallel score. Instead of like adding it on, maybe we say that like we have to be almost perfectly parallel. That's like another option. So where were we seeing like diagonals? It's like, yeah, like these roundabouts here are like fucking us. Oh, but I guess it's probably that this distance here is closer than this. which kind of lends back to the idea that we should be checking both nodes that we're looking at instead of picking the smaller one. So maybe for the distance score, we, instead of doing this, we say add this. That feels right. So we take the point on one side, we say, hey, how close are you to this fucking waypoint? This like way segment. How close are you to this way segment? We sum them up. There's like kind of something fucked up going on here where it's like, maybe we should. Oh no. If this is both closest point on the line, I think that's fine. You could argue that like maybe we should sum min distances to way overall, but this is probably fine. Again, it doesn't need to be perfect. It just needs to be like good enough so that it's like mostly correct. Oh, the reason this is flickers, by the way, is because as it's loading the map tiles, it re-renders the map every time. So this fixed the roundabout problem. And here it's fine for us to pick the roundabout because I think that on this crosswalk, it really does kind of feel like the roundabout should win. Here we're back to this line, which is good. Here we're picking this. That's great. That's great. That's great. Holy, oh, baby. Look at that. The diagonal's working. Yeah, this is probably good enough. This feels, what's going on here? That's kind of fucked up. But, you know, a couple misses, I'm not really worried too much about. It's, again, majority rules here. Because this overall feels pretty good. I think there's an obvious flaw in like the algorithm where looking at the points at the ends of the line doesn't make sense, right? And I think that that's probably causing some issues in some areas. But I mean, overall, it's pretty good. I don't know if you guys can see the blue lines here, right? Like you guys are like, I'm not just like scrolling around saying this looks great, and you guys are like, what the fuck is he talking about? Yeah, it's pretty fucking sick. Oh yeah, that's awesome. That's plenty good enough. So let's try to like look at like a busy street, like because the problem I actually want to solve is that like I don't want to walk down Granville. So even if it like catches, even if it only works like 90% of the time, that's like plenty good enough for the idea of like adding costs to walking down that street. And this is just, yeah, fucking awesome. That's great. That's really good. Really good. Here, this is interesting. So there's a bug here to look at for sure. Oh, this is actually maybe a little fucked up. So I bet you if we were to draw the tiles, we would see just like kind of something fucking stupid here. Oh, or maybe it's because the line segment. Here's like, no, I don't really see it. Yeah, I don't know what's going on here, but it's okay because it's only for 2 blocks. The rest of this is like. Yeah, I wouldn't be shocked if this is on a bucket tile. Just because of like stuff like this, like there's something fucking stupid going on there, but that's okay. Again, for the most part, good enough. Okay. Let's just tack on now. I think this is good enough to prototype adding costs to walking on sidewalks that are close to main streets. So let's see. Let's get rid of this like ppviz. We don't need this anymore. I don't think. But we do still need to run that function. So it's gonna look kind of like this. PPViz goes away. I guess we'll leave it around just to avoid changing too much code right now, and then we'll just comment out the rendering of the visualization, because I think we might want it back later. Does the parallel score have a lower weight than distance score? It has a higher weight, I think. Well, I guess it's kind of hard to say because the distance score is in like meters, and the parallel score is in like angle, like maximum 5 meters. I think is what it's set at. Parallel. Oh, it's actually, yeah, maximum 5 meters here. So the maximum that this can offset us is 5 meters from the closest road, which is something. No, sorry. The maximum the minimum this can offset is 5 meters. No. Yeah, this goes like infinity down to 0. So I don't know. This is just like the scaling factor, I guess. Who fucking knows? I don't have a good feeling for how this increases with angle change, to be honest. Because we did just pick a random fucking function. But we are also 15 minutes from the end of stream, so we have to focus the fuck up. We have to lock it in, baby. So let's kind of say we kind of did like we kind of did this. We did this at some point. So this is at some point before now. And let's do the adjust path planner. All right. So path planner. He now just needs to take in. Seems like parallel scores should only matter within some distance. Yeah, I think that I think it's likely that we want to cap both of them. It like probably we only want things that are like sub 30 degrees or something, and we probably just don't even want to look at things that are farther than like 10 meters or something. Maybe 10 meters is kind of short. I'm just looking around my apartment. If I'm like a couple meters tall, then like 5 of me, so maybe like within like 20 meters or something. But we can always tweak that later. I think the important and interesting part right now is the theory. And the theory is, who fucking knows? We'll make it work almost a little bit. Okay, so when we look up the node cost now, it's when we populate this node cost, I guess. We're going to have to look at the parents. So this is going to be in app.z. We're going to have like some sort of node costs thing, and it's going to be like recalculate node costs. We look at each of our ways and we see if the way matches, which is wonderful, right? But now we also have to check if ways for tag pair. So we look at all of the ways for this attribute. So we say like, I want to lower the cost for bike routes. And so we look at all the ways for bike routes. Now we also have to look at the node costs. We look at the, oh, right. So we're iterating all ways for this. And we also have to iterate all of our children, which means that we kind of stored this backwards. Maybe. We might want to go from way to node pair in order to populate this. Let me think about this. Or I guess we instead of doing this, we say for we want to do, we have the concept of going from node pair to way. That exists. So maybe we change our iterator here. Change our iterator to go through, instead of going through ways, can he go through node pairs? That might make sense. Where do we use this? We use one for set monitored cost. So when we change the cost, we iterate over all ways for this thing. And instead we just want to iterate over all node pairs for this thing. Sure. So we're going to change this to node pairs for tag pairs. Node pairs for tag pair. And oh, ow, 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 ow. Ow, 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 ow. Yoshi in Mario Kart 64, when he gets hit by a red shell. Ow, 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 ow. Or when he falls off the map or something. Fuck. Sorry, I'm just trying to figure out like what's like the easiest way to track what I'm trying to track. I'm trying to say I have this node pair. Is the parent of this node pair away for this thing? Okay, we're gonna say like for for 0 self points num points. We have an adjacency map. Get neighbors for I. We're getting somewhere. We're getting somewhere. For neighbors, we have point pair to parent. I guess we know we don't know this. I was gonna say we know that we will either have a parent or we'll match the tag, but that's not true. We might have both. No, I think that we will have one or the other. Fuck it. Fuck it. We're gonna do this for now. I don't think it's perfect, but I think it might be good enough. So we're gonna get the point pair to our parent. This is gonna be slow as shit, by the way. But that's okay. So we're gonna look. Const parent is point pair to parent, and we're gonna get from node ID and neighbor. Or else continue. Then for this, we can say parent metadata tag way tags parent value. If way tags contains, okay. If way tags contains our key value pair, okay, that sounds good so far. Then we have a fucking problem. So we set the multiplier. Sure. Yeah. Yeah. Why not? He's mad about something. Right, so this should be neighbor, not neighbors. And then we leave this here, because fuck it, because we need to, like, this is for the non-parent case. Okay. Fix me multiple tags, question mark. It's fine. It's fine. This is work in progress. But I think that should be enough. Do we clear the node cost anywhere? Self node cost, recalculate. Recalculate node cost surely should clear itself. Surely. And then here we should be like we get the node cost, or else 1.0, then we get the cost times the multiplier. And then we should probably do this down here as well. But this is with A and B, and I know that we should probably not fucking run the hashing twice, but we'll figure that out in the fucking future because I don't want to. All right. Then we're also going to change this so that when we set a cost multiplier, we just fucking recalculate node costs like a fucking dumbass instead of trying to do the intelligent thing. Because again, we are 5 minutes away from when I want to be done. So instead of doing something reasonable and correct, we will do something stupid that might get us a demo. This is like work. Anybody who's been at work and has sprint end in 10 minutes has done this before. and then they wonder, you wonder after you do this, why the fuck did they think it was almost done? I told them it wasn't almost done. They're like, well, you kind of cut like 40 corners to show us that you were done. It's like, shut the fuck up, man. Okay? Like, I know I did that, but why can't you just also why can't you think that I'm fast and do whatever the fuck I was gonna say you should do? I don't remember anymore. My brain's melting. Okay, so let's say that we have now a highway secondary cost. So if I am going from here to here now, right? He's gonna walk along the sidewalk along this main street. And I'm hoping now if I type here 2.0, oh, he decides to walk down the lane. Hell yeah, dude. Wait, that's fucking sick. That's sick. I mean, walking down the lane's not good, but then we can just fucking say don't do that either. Like, fuck off. You know? Walk down the next street. Isn't that fucking sick? Look at that. Look at that. It's so fucking cool. Holy. Oh, that's so good. That's so good. Holy shit. That actually makes me so happy because, like, this is actually, like, a usable, almost, right? Because we have a lot of bugs, but, like, this is, like, a usable new thing that, like, doesn't exist right now, as far as I understand. Right? Like, this is so fucking sick. Because, like, this is a problem that I have in real life, where it's like, fucking don't make me walk down Granville Street, and I feel like nobody else, like, wants that, and now I can just fucking have that. That's so fucking sick. Let's go. All right. So there's obviously a lot of cleanup to do here, right? Like, it's obviously not there. And so if you want to check out that cleanup, I will try to cover most of it in happy hour. So I'll try not to do too much off-screen work on this. But I think this is gonna be like the last main stream VOD of this. So if you guys want to check out, and you're watching on YouTube, like, continued on what we have to do to, like, clean this up, swing by on happy hour, or you can check out the archives on Patreon. We'll be back tomorrow live for transit stuff. So tomorrow I want to work on hooking up the bus system to this map. So if you want to see that, swing by tomorrow. If you are new here and you have not, you like what you saw, there is a YouTube link in the Twitch description where you can see our current playlist, Map Time, but there's also everything else is organized in the playlist. So if you want to see, like, us work on an operating system, or rewrite zlib for no fucking reason, or work on this, like, ball machine on the right, or work on a keyword decoder, this stuff's all there. There's a GitHub link in the Twitch description where this code will eventually end up, probably not in exactly this state, but it will get up here cleaned up. There's also all of our other projects on here if you want to check those out. What else do I usually plug? You guys should like, subscribe, and Twitch Prime, you know, typical streamer, YouTuber shit. Yeah, I'm happy with today, dude. I had a fucking good time. This is so sick. This is so fucking sick. Can we see it work somewhere else, like in a non-American city? This isn't American, so big win, already done. But also not right now. But I mean, I think that it would work. It's just I haven't tried it there, so I don't want to, like, deal with that. Okay, thanks for watching, guys. YouTube, bye, and Twitch, let's find someone to raid.